Welcome back. In the last video, we talked about schema, and in this particular video, we'll be talking about three-layer architecture itself. Okay. So three-layer architecture of the particular database itself. If you see this particular diagram very carefully, okay, you will see there are three type of levels are there. Okay, so one we call it the external view level. Okay, one is a conceptual view level, another is the internal view. Okay, external view, each of the individual how actually he is viewing that particular so you will have an external schema A, external schema B, external schema C. So schema, as we have already seen in the last video, it is nothing but the visual representation, right? So a user A, how he visually he see this particular the database, right? Okay, and user B, okay, he will be looking at schema B itself, or C will be looking at the schema C itself. Okay, right? So this is nothing but the external view itself, for the external individual how he is viewing this particular database. Now, in the conceptual schema, how exactly whatever he is viewing is how is conceptually it is represented. For example, in an organization, okay, we have employees, we have department, we have projects itself and all these things, right? So maybe schema he is only looking at the employee and project, where the schema B he is only looking at the employee and data department itself. But when in the schema C, he is looking at all the particular thing. Now, how this in the conceptual schema, how each of these employee, department and all, how is been represented. Typically, you can see it is represented in the form of some kind of tables and all those things. So that becomes your conceptual view, because each each of these entity, okay, will be nothing but a relationship in terms of RDBMS, right? Okay, and lastly, in the internal level, we you see how internally this particular it is stored, because we are talking this schema conceptual and nothing but a logical, and here we are talking about the physical thing. So if this is how and beautifully explained, right? It's like Mike is one user, Graham is another user, Jack is also another user. So they are seeing the external view. Okay, external view A, they are seeing the external view B. Okay, and these are mapped into nothing but the conceptual view. Okay, and this conceptual view is making is internally mapping into nothing but the internal structure of the database itself. Okay, schemas and mapping build and maintained are done by whom? Nothing but the DBA, which is the database administrator itself. Okay, so he is one who is responsible for this particular, how the schema and mapping has been built. Okay, so more precisely, if you see the example of the three level, okay, right? Say if I as an external, okay, I'm looking into the, suppose the customer, when you're talking about customer is taking certain loan and all this. So I see, I can see the customer having an ID, the loan will be also having certain ID. What is the amount of dollar that is taken? So this is my external, view itself, right? So customer is taking certain loan, he will be having an ID, suppose 101, loan number 1011, dollar amount in dollar, 876. But in the conceptual view, I see, customer loan itself as a table, okay? And I can see the customer ID is represented by some numbers. Like an size is 4. Loan number is also some number of 4. Okay, amount of dollar is also number and 7.2. Okay. And internally, I can see what kind of bytes and offsets, how the entire, storage is being done, which is nothing but the internal. Okay. So this external view, that is what as a user, I will see. Okay, right? For example, if you take another example like student, okay, so I can see the student ID, I can see his address, his name, okay, all this thing. So next in the conceptual, I can see a table with having student ID in the form of a number, okay, then student address in some of a character, and like this, and what the set of bytes and offset that is there in terms of in the internal. So that's become nothing but the internal. So in three-layer architecture itself, so we see three, okay, level, which we have the external view. Each of these user will having, or individual will looking into this, okay. Then we have a conceptual view, okay, right, and then we have an internal, or the storage view. So we have external, conceptual and internal. Okay, so we in the conceptual view itself, we have the conceptual schema, okay, and in the internal in the storage view we have the internet, and each of this externally one of the user will be looking on the schema. So this is something which we are talking about, right? Mike and Graham will say as an external view we look at the schema A, then the schema B, right? But all are mapped into nothing but the conceptual view, right? Okay, and the conceptual view is now really representing internal mapping which has been done with the database internal. Okay, and DBM is the one person who actually manage this or maintain this particular schemes and all this thing. So this example, where as an external I see customer ID, loan number, a dollar, I see this value, but when it is stored in a form of a floating point, right? Number with 7 and comma 2 means two precision and all this thing. So this become the conceptual, okay, where I was looking at a customer loan as a table itself, conceptual. This is what I as an external I see the view, and this is what the internally the customer ID, loan number, amount of dollars, how exactly how many bytes and offsets, and the way in which it has been stored. Okay, so tree level architecture is very important because this is one of the important question that is asked during the interview. I was talking about in the last session that you should know what is schema, what is database schema, what is database instance, and also about the system architecture in terms of three layer architecture. What is that? So three view, external, okay, that that conceptual view, and then the internal view. I hope the three layer architecture is clear to you. Okay, thank you.